Hello, happy whatever day you are looking at this. Welcome back to our next math lesson. This lesson is our fifth one in Unit 2, and it is all about rate of change. Now, rate of change, or ROC, is a ratio that describes on average how one quantity changes in relation to another. And this is the way we calculate it. So what you would do is your output 2 minus output 1. And on the bottom, we would do our input 2 minus our input 1. And how we would say this is our change in output over our change in input. So output 2 minus output 1 over input 2 minus input 1. The way that you'll most often see it in our class that we'll calculate it is our y2 minus our y1 over x2 minus x1. So again, this we could read as our change in y over our change in x. And that just means our second y value minus our first y value, and then our second x value minus our first x value. Now we can calculate rate of change when we're given both tables and graphs. So the first one we're going to do is calculate the rate of change in a table. So I ask you to calculate the rate of change between 1990 and then 2010. So in my table here, I'm going to find those 2 years. So we have 1990 is right here. And then we have 2010 right here. It's important to remember that our tables are always x and then y on the right. So now I can see my 2 points. I am going to write them here just to make them a little bit more clear. So we have point 1, which is the 1990 point. So it's 1990, comma, 250. And then we have our second point here, and that's for 2010. So it's 2010, and then 310. And again, ordered pairs are written x and then y. So now when we set this up, again, remember it's y2 minus y1. So our y from our second point minus our y from our first point. So our y from our second point, point 2, our y value was 310, minus y from my first point, point 1, y was 250, over x2, x from my second point, which was 2010, minus x from my first point, which is 1990. And then we do that calculation. I'm going to just pull up a calculator here. Alrighty. How can I make this smaller? Let me do this. Whoop. Oh, there we go. Okay, so we have 310 minus 250 equals, and that gives me 60. So we have 60 on top over, and then 2010 minus 1990. Minus 1990, and that gives us 20. And then now we'll go ahead and we'll do this division. We'll do 60 divided by 20. And we get 3. Okay, but now we need to look at what this represents here. And I think the easiest way to do that is let's include our units in this fraction. So in the top we had our y values, which was population in millions. So pop in millions over, and then the 2010 minus 1990 was our years. And that actually tells us what this 3 means. So this little line here we can say as the word per. So we have 3 pop in millions per year. And what that means is because the 3 is positive, this means that my population is growing by 3 million per year. So again, include your units in the fraction here. And the fraction means the word per. So this would mean my population is increasing by 3 million per year. Excuse me. I think another important thing to remember that I'll actually add up here is if you have a positive, that means it is a growth or an increase. If you get a negative number, that means it's a decrease. So if this was like -3 instead of a +3, that would mean your population is decreasing in 3 million per year. Okay, I want you to go ahead and try to calculate it for this one, 1980 to 2000. So do your y2 minus y1 over x2 minus x1. Make sure you include your units here and tell me what your final answer is. All right, I will see you in a second. Alrighty, so I already have this one set up really quick. So my final answer here, I did write it down. So make sure you have this. Hopefully this helps a little bit. So we said the population was growing, because this is positive, by 3 million per year. And then to be even more specific, we can say between 1990 and 2010. Okay, so I already have your points set up here. This is what you should have had when you started this problem. Point 1, point 2, 275 minus 225, we get 50, and then 2000 minus 1980 gives us 20. And then we can actually do that division here. 50 divided by 20, and we get 2.5. So we have there we go. So 2.5. And then again, this was from the same problem, so our units are the exact same. So up top we had our population in millions. Bottom we had our years. So here again, we can say my population was, this is positive, so it's increasing or growing by 2.5, and then now we need to include the units. So this was by population in millions, or 2.5 million. Fraction is per, and then we have year. Between 1980 and 2000. So again, my population was increasing because it's positive by 2.5. I'm going to change the wording here. I don't like this, by 2.5. We'll do it like we did about 5 million per year. Beautiful. So even now we can then look at both of these and we can determine that between 1990 and 2010, they had a larger population growth because here we had a 3 versus a 2.5. So once you calculate the rate of changes between two different sections in your graph, you're then able to compare them to, which is really great in when you're analyzing data and whatnot for different scenarios. Okay, so now we're going to try some with a graph. So calculating it is the same exact way. It's just you have to find your points from a graph instead of a table. So here we have a wildlife biologist is studying an endangered species of salamander in a particular region. She finds the following data. All right, and we have a lovely graph here. And then I ask, what is the average change in numbers of salamanders per year from 2000 to 2003? So on 2000, so years after 2000, so that means I'm looking here first because I'm starting at 2000. So I'm going to look at what that point is. So at 2000, my number of salamanders in thousands was 4050. And again, this is in thousands, so I'm going to actually just write 50,000 here. It's a little easier than millions. Okay, so there was our point for 2000, and then we have 2003 next. So for 2003, if this is 2000, this would be 1 year after 2000, so 2001, 2002, 2003. So now I'm looking right here at the year 2003, and we're going to estimate, so I know that this is 10. This isn't like halfway. I'll say that's about 7. So we have 7,000. Okay, and then now we have our 2 points, and now we can calculate it. So point 1 was 2,000, and then 50,000. Point 2 is 2003, and then 7,000. And again, these are x comma y. So now let's go ahead and calculate. I'm going to zoom in a little bit here just to help me out. So y2, 7,000, minus y1, 50,000, over x1, x2, which is 2003, minus x1, which is 2,000. Okay, and again, this is my number of salamanders, and this is my years. Okay, let's go ahead and do this. So 7,000 minus 50,000 gives me a negative 43,000. And then 2003 minus 2,000 is 3. We can do that division, and we get negative 14,333. So now what does this mean? So my final answer is my salamander population is, let's see, I have negative 14,333, so is my population increasing or decreasing? It is decreasing by this number, by the rate of change. My salamander population is decreasing by 14,333 per year. Beautiful. Okay, there's another graphing one right here. Go ahead and give that a try. Write out your 2 points, calculate it, and try to explain to me what that number means. Pause me when you are, or come back and play me when you're ready. All right, so once we have this set up, so we had week 6, which was right here at 208, and then 10, 60 down in here. 60 minus 208 gave me negative 148, and then 10 minus 6 is 4. And again, this was, our y was number of people. So we have number of people, fraction means per week. And so now I can say what was happening to my population, or the number of people attending. So we can say the attendance at the play decreased by 37 people, number of people, 37 per, and then week. All right, there's some independent practice down below. Go ahead and give them a whirl. We go back and forth with a table, a graph, and then a table and graph where you have to calculate it 2 times and then compare. Let me know if you have any questions.